Jackson.
Say it's Andrew.
Andrew.
Hi everybody! Here's our first lesson. And if you didn't catch it, this is Jackson. And this is Andrew. And today we're going to do a lesson on heat capacity and calorimetry. Alright. Alright guys, are you ready to help me?
Yeah.
Okay, so today we're going to talk about what has more heat. And by the end of the lesson, you should know what the difference between heat and temperature is. So the first thing we're going to do is we have 2 glasses of water and they have the same amount of water in them. And Andrew, can you tell me, is it hot or cold?
Cool.
Is it cold?
Yeah.
Is it cold? And what's this one? Is this hot or cold?
Hot.
Well, how do you know? You got to touch it.
It's hot.
Is it hot?
Yeah.
So the question I have for you guys is, which one has more heat? Does the cold one have more heat?
No.
Or does the hot one have more heat?
The hot one has heat.
The hot one has more heat?
Yeah.
And what do you vote? Does the hot one or the cold one have more heat?
Cold one.
Oh, silly dude.
Not the cold one.
Not the cold one? Alright, so we vote that the hot one has more heat. And if you voted that too, you'd be right. It is the hot one. But there's a lot more to heat than just temperature. So, here we go. You guys got lots of water in there?
Yeah.
Yeah? Do you have more water than this glass here? Oh, hold on.
You put it in. It's hot.
Yeah. Well, is it the same temperature?
Yeah.
Yeah, it's the same temperature as the bath, isn't it?
You put it in. You put it in.
Okay, is there more water in the bath or more water in the glass?
More water in the bath.
Good. Now, everybody, what do you think? Now, before I emptied out the glass, what had more heat? Did the bath water have more heat?
Yeah.
Or did the glass of water have more heat? They had the same temperature, but the question is, did they have more heat? So, maybe if you're thinking about it really hard, you can figure out that it's not just temperature that decides heat. It's also the mass of whatever substance you have. So, because there's a greater mass of water in the bathtub, even though there's the same temperature, the water in the bathtub has more heat. Is Jackson's flash? Aw, nuts! Oh, you weren't supposed to see that. Anyways, here we go. So we're talking about heat. And if you forgot from lesson 5.1, heat symbol is Q. Now, don't get heat mixed up with enthalpy. Because enthalpy is the change in energy during a transition between two states, and heat is a kind of energy. So delta H can describe a whole bunch of different kinds of energy, but heat is a very specific kind of energy. So don't get those two mixed up. So Q is heat. Now, from looking at the glasses of water, you know that there's temperature involved. And hopefully you remember that temperature equals T. So how much heat you have depends on how much temperature you have, or how high the temperature is. And if we look at just a glass of water compared to a bathtub of water, you know that the mass of whatever object or compound you're looking at also comes into play. But there's one other thing that we're kind of missing, because if I had a glass full of water and I compared it to like a glass full of liquid metal, there's a difference there. They're 2 different compounds. And the difference is what we call specific heat capacity. And that symbol is C. Now, if you put all these together, you get the equation Q equals MC delta T, where delta T equals TF minus Ti. Now, before we talk about how to use this particular equation, we need to talk about what specific heat capacity is. So there's two kinds of C, or specific heat capacity. There's just straight specific heat capacity, which is the amount of energy needed to raise the temperature of 1 gram of substance 1 degree Celsius. But heat capacity, which isn't specific, just heat capacity, is the amount of energy needed to raise the temperature of an object or a sample 1 degree Celsius. And for heat capacity, the mass doesn't have to be known. Now, if you look at all of this, that means that if C is about 1 gram being raised 1 degree Celsius, then delta T is also in degrees Celsius. So when we look at the units of Q, let's take a look at them. So if Q equals mass times specific heat capacity times temperature, and mass would be in grams, and specific heat capacity is in joules per gram per degree Celsius, then that means this temperature also has to be in degrees Celsius. Now, if we look at all this, grams will cancel out, degrees Celsius will cancel out, and that means that the units of heat are joules. So what's really important when you use this particular equation is that you know that if they give you the temperature in Kelvin, you have to convert it to degrees Celsius. Tomorrow you're going to do a lab so that you can learn how to use this particular equation. See you tomorrow!